Okay, so we're just kind of playing around with the unit circle here, and we're going to look at this point right here on the unit circle, which would have an angle of 0. Agreed? All right, next to this point, would you please write the coordinates of that point? What's the x-coordinate of this point? How far over to the right of the origin is it? 1. What's the y-coordinate of that point? 0. Okay, off to the side here, I would like you to complete the following equations. The sine of 0 equals the cosine of 0 equals, and the tangent of 0 equals. Go ahead and complete those for me, please. No calculators. Don't be touching that calculator. You don't need a calculator. You got x and y coordinates right there, and those x and y coordinates are related to sine and cosine. All right, what is the sine of 0? The sine of 0 is 0. Why? Because the y coordinate of the point will always be the sine. So the y coordinate is 0, so the sine is 0. What's the cosine of 0? 1, because cosine is the x coordinate, and the x coordinate is 1. What's the tangent of 0? Tangent is sine over cosine. In this case, 0 over 1 is going to be 0. All right, so we're going to keep going around the circle to a 90-degree angle. I would love for you to please write me coordinates, x and y coordinates for that point. We're still talking unit circle, so the radius is a 1. And let's do the same thing again. Could you please write the sine of 90, the cosine of 90, and the tangent of 90? All right, we should be getting close here. The sine is the y-coordinate, which is 1. The cosine is the x-coordinate, which is 0. The tangent is sine divided by cosine. 1 divided by 0 is undefined. Please do not write NA or 0 or the empty set. Right, undefined. All right, before we go, I'm going to do the other two important points here, but let's go back to problem 69 here. Is the cosine of 90 defined? Yeah, it's totally defined. It's 0. We just found that it's equal to 0, so that's not it. So we've eliminated our top 3. What about the cosecant of 90? Remind me, which of these goes with cosecant, sine or cosine? Sine goes with cosine, and to find the cosecant, you would just take the sine and take the reciprocal. What's the reciprocal of 1? 1 over 1, which is 1. The reciprocal of 1 is 1. So the cosecant of 90 is defined. It's 1. So that's not our answer either. The secant would be the reciprocal of cosine. What's the reciprocal of 0? That would be 1 over 0, which is undefined. We found our undefined. It's the last one. So this would have been the answer to number 69. That's the one that's undefined. While we're here, though, before we continue on, would you please go ahead and do the same thing we just did for our other two. These are called the quadrantiles. We'll write that down here in a second. But write me some coordinates, and I want to see the sine of 180, the cosine of 180, tangent of 180, the sine of 270, cosine 270, and tangent of 270. So you guys have heard of quadrants before. Are we familiar with the quadrants? If I ask you to focus your attention on quadrant 4, do you know what quadrant I'm talking about? That'd be this one. Are we good on that? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so we're going to be talking a lot today about what quadrant is an angle in. Well, there are 4 special angles that are not in any quadrant, and they are these special quadrants. They're on the lines in between the quadrants, right? And these angles are called the quadrantiles. So one of the big goals of today is going to be to evaluate sine, cosine, tangent, secant, cosecant, cotangent for various angles on the unit circle. And for many of those, we're going to be accomplishing that by doing a thing called a reference triangle. However, we can't do reference triangles for the quadrantiles. So the way we're going to evaluate sine, cosine, and tangent for the quadrantiles is just what we just did. We're going to think about the x and the y coordinates of those points and relate the x coordinate to the cosine and the y coordinate to the sine. And we know that tangent is sine over cosine. So this is how we're going to deal with quadrantiles, not just today, but for the rest of the year. Anytime we get an angle that's a 90, 270, 180, 360, any multiple of 90, that's how we're going to be doing it. Any questions on that? Are we feeling pretty good about that so far? X is the cosine, Y is the sine. We use that over and over and over and over and over again. I want to talk about number 70. These multiple choice questions usually involve some higher level thinking, which I like. It says theta is the smallest angle in a 3, 4, 5 right triangle. So I'm going to just draw, oh my gosh, that is a 3, 4, 5 triangle. Didn't mean to do that, but it happened. Here's the 3, here's the 4, this would be the 5. Which one of those angles would be the smallest one? That one or that one? The lower one or the upper one? Smallest angle is across from the smallest side. If they said theta is the smallest, that must be theta. And they're asking us for the sine of theta. Sine of theta would be 3 over 5. That one was pretty straightforward. 71. Going back to Algebra 1, you guys learned that if I had a slope of a line, or if I had a line that had a slope of, say, 2 over 7, I could create another line that would be perpendicular to it as long as the slope of the second line is equal to what? Negative 7 over 2. When we're looking for a perpendicular line, there's 2 things. We need it to be opposite signs, and we need a reciprocal. Okay? All right, so let's try and apply that to our problem. They told us that we have a slope of a line, and the slope of our line is sine theta. And they would like us to find the slope of a perpendicular line. So let's apply both of those to it. So if I want a perpendicular line, it needs to be opposite. So I'm going to stick a negative in front of it. And remind me, what is the reciprocal of sine? Cosecant. All right, questions on that? On the final, I think it's on the final exam, and I think it's the last question. This would be the FHS final. It's multiple choice, and the question is, can Mr. Ganger dunk a basketball? And the answer options are the 6 trig functions. What one would be the correct answer? Yeah, cosecant. I don't know who wrote that. It was probably Mr. Work, who's retired several years ago. All right. There was a time when he could. Anyways, where are we going next? Let's go into our packets here. Last chance. Do you have any questions? that I can address from the assignment? Anything else we can talk about? Feeling pretty good on that. Okay, I'm going to be jumping around a little bit today. These sometimes you make some notes and then you start looking at them and you're like, I don't like the way this works out, but that's okay. We're going to make it work. I'm going to get you some information today about angles, and we're going to be really diving into the unit circle. We'll talk about reference triangles and what those mean and how we can use those to solve some problems. So let's start off with the idea of a standard position of an angle. We actually talked about this a bit on Monday. The whole idea with the idea of a standard position of an angle is that the positive x-axis is 0 degrees, 0 radians. And as we rotate counterclockwise, the angles get bigger. So we start at 0 here, then this would be 90, 180, 270, 360. It turns out that if we rotate the other direction, the angles get smaller, which means in trigonometry it is possible to talk about negative angles. Negative angles don't make sense in a geometry context because you can't have a shape that has a negative angle. But in trigonometry, we're going to be using trigonometric functions to represent things other than shapes. Sometimes it'll be the temperature, the outside temperature over time. And the angle is actually going to be like the time of day. So in that case, it makes sense to have a negative time of day because if I want to know what the temperature was 6 hours ago, then I put -6 into my function. All right, so we still need to account for that visually, so we just say if we have a negative angle, we just rotate this way around. So I want to sketch a couple of angles onto this thing in standard position. We're not going to do all these. Let's start with 120. So where would 120 be? So this is 0 degrees. We're going to start at 0 degrees. It's positive 120, so we're going to rotate around. So that gets me 90 degrees, right? And then I need to go how much further? About another 30 would get me to about right here. This would be about where 120 is if this was 90 and this was 30. Could you guys estimate about where 315 degrees would be? 315, that's almost all the way around the circle, isn't it? If I start right here and I start rotating 90, 180, 270, plus another, I would need another 45 to get to 315. So that would be the position of a 315 degree angle. This 120 probably should have been a little more like that. How about a negative 45 degree angle? Bless you. Where would a negative 45 degree angle be? Oh, it's going to be right here? What? Yeah, I guess so, because we're going this way, so this is negative 45. Okay, cool. All right, so let's jump down and talk vocabulary down here. Like I said, we're going to be jumping around quite a bit today. We talk about angles. Oftentimes we're going to talk about the initial side and the terminal side. Initial is the beginning, terminal is the end. In standard position of an angle, the initial side would always be the positive x-axis. But in general, when we're talking about an angle, I'm going to do this. If I start here and go to here, then my initial side would be this one, and this would be my terminal. In standard position, we said that 0 is the positive x-axis. The positive x-axis. So if we're talking standard position, then the initial side is set as the positive x-axis. We define positive angles as angles that are rotating counterclockwise from the initial to the positive. And negative angles are defined as ones that are rotating clockwise from the initial to the terminal. If you look at the angle that I drew here, if this is my initial and this is my terminal, would I be labeling this as a positive angle or a negative angle? Is this arrow rotating the same direction as a clock? It is the same direction as a clock, right? Which means it'd be a negative. This would be a negative angle. I would guess like negative 25 or 30 or something. All right, and that leaves us at coterminal angles. Anybody know what coterminal angles are? What do you want to guess? Like the 315 and the negative 45? That's a great example. Yes, those are coterminal angles. Coterminal, right? Kind of like co-workers. What's special about co-workers? They work at the same place. Coterminal angles would terminate at the same place. So coterminal angles are angles, they are different angles, but if you're starting in standard position, you're going to end at the same spot. So an example of some coterminal angles would be 315 degrees and negative 45 degrees. I'm going to give you some other angles, and I want you to find me a coterminal angle with it. Okay? So what if I told you I had a 240 degree angle? Could you find me a negative angle that would get me to the same spot? Now, if it's helpful, you could always draw yourself a little picture of what 240 would look like. 240 is going to be all the way half of the circle plus another, that's 180, so I need another 60. So that'd be 60, and this would be 30. So if I want to rotate negative, I need to go negative 90 plus another 30. That would be the same as negative 120. Let's try another one. If I told you I had an angle of 150 degrees, could you give me a negative coterminal angle for that? We got it? What would it be? Negative 210. Nice. One more. If I gave you, let me give you the negative one this time. How about negative 100? Could you tell me the positive coterminal angle for negative 100? I think some of you, I feel like some of you have seen the pattern here. Do you see the pattern that's going on? What are you seeing? Okay, I like that. So if we thought about these as just like the magnitude of it, like the absolute value of it, these would all add to 360. Yeah. Try this on. Does this sound correct? These two angles are 360 degrees apart. If I started at negative 45 and added 360, would I not get to 315? Same thing here, from here to here is 360. Does that make intuitive sense to you? I want you to think about this for a second. Let's say I'm standing at the origin right here, and I'm facing towards, I don't know, this direction here. So let's say I'm facing at 135 degrees. And I do a full spin of 360, exactly 360 degrees. Does it make sense that I would still be facing the same direction after that spin? Yeah. Would it matter which way I spun? Left or right? All right. Then tell me another coterminal angle for 315 and negative 45. Someone get me another one. There's a third. Feel free to use your calculator if you like. You're on the right track. Keep going. 675 degrees is also coterminal with those two. How did you get that 675? I'm facing at 315 and I spin around 360 degrees, and that gets me to there. All right, so we can actually have angles that are bigger than 360 degrees. If I asked you to find me another coterminal angle, could you find me another one? So we've got another one, negative 225, and you did that. Not for this one. Hang on. Oh, that would have been for another one of these. But what do we do to find coterminal angles? What's the kind of the key concept here? If I give you an angle and I ask you to find me a coterminal angle, what are you going to do with that angle? You could subtract 360, or you could add 360. And then if I asked you to find another one, you could add another 360. And if I asked you to find another one, you could add another 360. If I gave you an angle right now and I asked you to find me 100 different coterminal angles, 50 positive and 50 negative, do you think you'd be able to do it? It'd be super tedious and boring, but it'd be really easy, right? So we just add full circles and subtract full circles. So that's one of our big concepts for today, is that we can go over 360 and we can have negative angles. So a lot of times we're going to be faced with these kind of weird looking angles, and they're not bad angles, but I would rather have happy angles. My happy angles are the ones that we wrote on our unit circle sheet on Wednesday. I like angles between 0 and 360 because I've memorized the unit circle from 0 to 360. So it'll come up a lot in our work where we're going to get one of these in a problem. I'm going to be like, I don't want to deal with negative 150, but that's okay because I can just deal with a happy angle that would be coterminal to negative 150. Can you find me a nice happy angle that's coterminal to 150 or negative 150? If I didn't want to do a lot of math because it's mental math because it's Friday, I could just take negative 150 and do what with it? Add 360. 210. 210, I like that. I know that one. That one's on my unit circle. Could you guys find me some happy angles for these other two? Sometimes you might need to subtract 360. Sometimes you might need to add or subtract 360 more than once. What'd you find? They're all 210, which means what? They're all coterminal with each other. They all get us back to 210. All right, now the reason coterminal angles are important is because since they get us to the same spot on the unit circle, that means if I have a bunch of angles that are all coterminal, the sine and the cosine and tangent of those coterminal angles will all match each other, right? Because the sine and the cosine are just based on the x and y coordinates, and we're getting back to the exact same spot, right? So what I know for a fact is that any of my 6 trig functions, I'm just going to go with cotangent for some reason. I know that the cotangent of 210 is the same as the cotangent of negative 150, and that's the same as the cotangent of 570, and that's the same as the cotangent of negative 510. So this is useful to us because sometimes we're going to end up with some weird angles like this that we don't really want to deal with because we're not familiar with it. But we can always just transform that angle into a coterminal angle that is somewhere between 0 and 360 and then deal with this instead. So in your assignment, you may be asked to find the cotangent of 570. My first step would be to say, not a big fan of that. I'm going to subtract 360. Oh yeah, 210. I know where that is. And I would change it into that first. Does that make sense? Awesome. Okay. I think we're ready to go on to the back side of the page. We've got some redundancy here, so I'm going to be skipping around a little bit. We've already done coterminal angles. We already did this stuff up here. I'm going to skip the 300. Let's go to this. So we can find coterminal angles for angles that are in radians as well. The only difference is instead of adding multiples of 360, we're going to add multiples of what? What's a full circle in radians? 2 pi. Now, often our angles in radians are often expressed as fractions with a denominator. Common denominators that you would see would be 2, 3, 4, and 6. So sometimes when I'm adding and subtracting 2 pi, I'll think of a fancy version of 2 pi. For example, if I've got a problem and my denominator is a 2, instead of thinking of 2 pi, I'm going to think of it as 4 pi over 2. 4 pi over 2 is 2 pi, right? It's just a fancy version. What would be a fancy version of 2 pi that would have a denominator of 3? 6 pi over 3. Or if I wanted a denominator of 4, we could think of it as 8 pi over 4 or 12 pi over 6. This just helps us do our mental math a little bit faster. So what I'm going to do here, if I want to find 2 positive and 2 negative coterminal angles for this 5 pi over 3, I'm just going to add 2 pi. I'll do it a couple times. But in my head, I'm going to be thinking of that 2 pi as something over 3. What is 2 pi? That would be 6 pi over 3. And we'll just do that a couple times. So 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. Plus another 6 pi over 3 would be 17 pi over 3. If I wanted to keep going, I could do 23 pi over 3 and 29 pi over 3 and 35 pi over 3 and 41 pi over 3. We could do this all day if we wanted to. Let's go back the other direction. Let's subtract 6 pi over 3. So 5 pi over 3 minus 6 pi over 3 would be negative 1 pi over 3. Minus another 6 pi over 3 would be negative 7 pi over 3. And then I could keep going if I wanted to. I have a question. I want to make sure this is clear to everybody, so I'm curious if somebody who it is clear to would be willing to put it into words. Why am I adding 6 pi over 3? Why am I adding 6 pi over 3? It's the same thing as adding 360. Good. Because 6 pi over 3 is 2 pi, right? And so that is a full circle. So we're just adding full circles. And the reason I'm doing this version of 2 pi instead of just 2 pi is because it's just easier, right? It's easier to add fractions that have common denominators. Now your calculator will do this too. If you ever had to use your calculator for something weird, you can add radians in your calculator. Just leave the pi off of it. So if I type 5 over 3, okay, that's 5 pi over 3. I'm just leaving the pi off of it. And then I'm just going to add 2. Okay, it's 2 pi, but I'm leaving the pi off of it. And then I'll math frac it. And I get 11 pi over 3. And then I could keep adding 2 pi's. I just don't type in the pi. And put a math frac after that. So here we go. 17 pi over 3. 23 pi over 3. 29 pi over 3. So you can use your calculator to do this fraction work if you want to. Just leave the pi's off of it. And make sure you write the pi in when you write down your final answer. All right, and how is that useful? Because the cosine of 17 pi over 3, boy, that's a weird angle. No worries, though, because if I got to deal with that, I'll just figure out what the cosine of 5 pi over 3 is, because they're going to be the same. Okay, that's the reason we do this. because the trig functions will always match if your two angles are coterminal. All right. Let's see what you guys can do with this. This is similar to some problems that you'll see in your assignment. Could you please find me a nice, friendly, happy coterminal angle for each of these? I'll give you a little trick on your calculator here that may be useful to you when you got to do the same thing over and over again. If you look up here, type in 2300 and hit enter, and then do minus 360. You see how it says answer minus 360? Now, every time you hit enter, it's going to take the previous answer and subtract 360. So instead of having to type that over and over and over again, I can just keep hitting enter, 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 enter until I see an angle that I like. Negative 37 over 6. I'm going to add some 2 pi's to that. Think of that as plus 12. I did that in my head. Did that work out? Is that what you guys got for the second one? 1 pi over 6. Maybe I'll check it in my calculator. I'm going to start with negative 37 divided by 6, math frac, and then I'll do plus 2, math frac, negative 25 pi over 6, negative 13 pi over 6, negative 1 pi over 6. Yep, there we go, 11 pi over 6. All right, questions? You guys are doing really well. We need to move on, and I need to talk to you about reference angles. Actually, we need to do some work with positives and negatives first. That work that we just did a moment ago, where did I put it? Here we are. Nope, that was my other class. Oh man, I'm losing stuff. Here it is. Okay. I want to talk about something really quickly. This is our unit circle, right? We talked about our quadrantiles. I want to also talk about the quadrants now. So I'm going to draw, actually we'll just use this one that's on here. We've got our 4 quadrants, and if you'd like to, you could draw your unit circle in here. Although this doesn't really involve circles. I want you to think of a point that is somewhere on our unit circle in this quadrant, and I would like you to tell me about the coordinates, the x and y coordinates of that point. And I'm not interested in the values, I'm interested in the sign as an SIGN. Is the x coordinate positive or negative in this quadrant? Positive in the y coordinate, also positive. Which means in this quadrant, all of the angles in this quadrant are going to have a cosine value that's positive and a sine value that's positive. And actually a tangent value that's positive also. Agreed? All right, so what we're going to do right here is we're going to determine where is cosine positive and negative and where is sine positive and negative. So let's go around our circle into the second quadrant here. Something changes, bless you. What changes? X is now negative in this quadrant. Y remains positive. What's that tell us about angles in this quadrant? Well, the cosine of every angle in this quadrant is going to be negative. The sine of every angle in this quadrant is positive. Could you guys go ahead and do the same thing for the other 2 quadrants? So this is going to be really important. This is something that we're going to be thinking about in almost every problem we're going to do moving forward from here. You'll be asked to evaluate a sine or a cosine or a tangent of a particular angle. We're going to get into how to find the value of that sine or cosine or tangent in just a moment, but for right now, let's focus just on the positive or negativeness of that. So 315 degrees, what quadrant would that fall into? 1, 2, 3, or 4? 315 would be here in quadrant 4. Is the sine going to be positive or negative in quadrant 4? Negative. So 315 degrees will be negative. We'll talk about what the actual value is here in a little while, but for right now, it's negative. All right. Secant of 4 pi over 3, why don't we think of its partner? Secant goes with cosine. In the reciprocal function, secant, cosecant, and cotangent will match the same sign, S-I-G-N, as their partners. So if cosine's positive, then secant's positive too. If one of them's negative, then the other one's automatically negative, okay? So think about where 4 pi over 3 would be. 1 pi over 3 is equal to how many degrees? We need to start getting pretty good at these. Pi over 3 is 60, so 4 pi over 3 would be 4 times 60, or 240, which would be in this quadrant. Is cosine positive or negative in this quadrant? Cosine is negative, then that means that secant must also be negative in that quadrant. Oh, they snuck a negative angle in here. We're not bothered by that. The tangent of negative 100, we know what quadrant that would end up in. Negative 90 would be here. It's a little past there. So we're in quadrant 3 still. Is tangent going to be positive or negative in this quadrant? Tangent is sine over cosine. Negative over negative is positive. Ooh, this next one's very tricky. Here's a trick question. Which quadrant is 180 degrees in? It's not. It is a quad something. It is a quadrantile. 180 is a quadrantal. So we can't rely on positives or negatives here. We're going to think back to where is 180 degrees? It's right here. They're asking us about the sine. The sine would be the y-coordinate, which is 0. So it's not positive, it's not negative, it's 0. How about the tangent of 3 pi over 2? 3 pi over 2 would be what? Pi over 2 is 90. So 90, 90, 90, because there's 3 of them, would be down here. So it's a quadrantal also. So we think about the coordinate 0, negative 1, and do the y over the x, or the sine over the cosine. We're going to get undefined for that one. Okay. Folks, we're going to go ahead and move into our notebook now. I'm going to start. The remainder of our notes are going to be examples from the textbook, and they're from the same sections of problems that you're going to be doing in your assignment. So you should have an example for each section as long as we're able to get through all these. If you have your textbook with you, it may be useful for you to have that out. So this is going to be in your notebook. There is a little note at the bottom of the page we were just on that says that we're going to do some examples in our notes. You could put a star next to that in case you're looking at your notes later and you're like, I don't know where to find an example of this. Before we get into this, I need to tell you a little tiny bit about the idea of a reference triangle. All right, and I got to do this quickly, so I need your attention. So you guys, if you'd stop the side conversations, let's do this. Reference triangle. All right, there are a few rules about a reference triangle. When we create a reference triangle, these rules are that it must be a right triangle. The reference angle is at the origin. So we're going to position it so the reference angle, missed a letter there, is at the origin. and one leg is on the x-axis. So those are the key rules for a reference triangle. We're going to be drawing lots of reference triangles in this unit. So before we get busy on these examples, I want to give you some examples of what a reference triangle would look like. So I'm going to go ahead and draw an XY axis. I'm going to pick a point in one of my quadrants. This is just, I feel like, the second quadrant for this one. And I'm going to create a triangle. Now it needs to be a right triangle, and one of the sides has to be along the x-axis. So this is what my reference triangle would look like. And my reference angle would be this angle right here. Now I want you to imagine that this reference angle is a 40-degree angle. Do you think you could draw me a reference triangle in the first quadrant that would also have a reference angle of 40 degrees? Now keep in mind it's going to be a right triangle. That 40-degree angle needs to be at the origin, and your triangle must connect to the x-axis. So that reference triangle would look like this. Let's do it on the same grid here, on the same XY axis. Could you draw me a reference triangle in the fourth quadrant that had a 40 degree? I need to see your assignment before you leave. I need to see your work. Set it out here. You got 3 that you're going to show me today. Unless you don't have them. Okay, that's fine. Do you have a note to leave, or? For wrestling, gotcha. Okay, have a good meet. All right, draw me a reference triangle in this one that would also have an angle of 40. I'm thinking that one right there. Yep. And why don't we go ahead and do one in this one too. Angle at 40. Remember, it must connect to the x-axis. Ooh, I didn't do a very good job of making these triangles the same size. They really should be the same size since they have the same reference angle. Heck, while I'm at it, I'm going to draw this one again. I mean, it kind of makes a fancy looking bow tie sort of thing, right? Now, if I'd been a little bit more careful with my triangles, I want to point something out to you guys. I'm waiting for some people to look up at the screen here. If I had a point here, and I don't know what the coordinates of this point are, so I'm going to make up some symbols for it. It's going to be smiley face and heart symbol, okay? If I had the coordinates of that point and it was smiley face, heart symbol, could you tell me what the coordinates of this point would be? Wouldn't the y coordinate be exactly the same? They're right across from each other. It'd still be heart symbol. But the x coordinate wouldn't be smiley face. It would be negative smiley face, right? And wouldn't these 2 points also have smiley faces and heart coordinates, just with some negatives thrown in? Yep, this one would have a y coordinate that's negative. This one would be, they'd both be negative, right? So the idea of a reference triangle is, what we're going to do is we're going to draw a reference triangle that's always going to be have an angle between 0 and 90, so this limits how much work we need to memorize with the unit circle. And we'll just keep in mind that when we're doing these reference triangles, that the x and y values are always going to match no matter where our reference triangle is. The only thing that we got to worry about is whether we're going to throw a negative on the x and y values, okay? So let me show you how this is going to come out, okay? So we're going to do our first problem now. And this is number 4 this is on page 381. If you have your books, it would probably be helpful to have them out so that you can actually see what these problems look like. But I'll go ahead and draw what I would put into my notes. Was it 4 that we were going to do? I want to make sure that I'm doing the right problem here. Yes, 4 was the first one. I'm just going to draw exactly what they put in the textbook. It's an XY axis. It's got a line heading out into the 4th quadrant, and it's got some coordinates of a point at the end of that line, 4, -3. And then they've drawn an angle that starts in standard position and goes around to here. So this is theta here. And the instructions say evaluate the 6 trigonometric functions of the angle theta. So our final answer, we're going to have sine theta, cosine theta, tangent theta, and then cosecant, secant, and cotangent of theta as well. So we'll leave a space there for our answer. A couple questions while people are getting stuff copied down. Is this point going to be on our unit circle? Is this point on the unit circle? It is not on the unit circle. How do we know it's not on the unit circle? What's the radius of the unit circle? 1. This is outside of that, right? So it's not on the unit circle, but that's okay. We can still use what we know about angles, and we can use reference triangles. So before we get into drawing a reference triangle, let's use what we know about the x and y coordinates of these points to label positive and negative for all 6 of this. Okay? So I know that the x value is positive. That tells me that my cosine is going to be positive, which means automatically my secant is also going to be positive. I can see that my y coordinate is negative. That tells me that my sine is going to be negative, and also my cosecant. And what's that tell us about tangent? Sine over cosine would end up being negative for both of these. So we got positives for our cosine and our secant. We've got negatives for our tangents, cotangents, cosines, and cosecants. All right, now all we need to do is come up with a ratio or a fraction to fill in after those positives and negatives. To do this, we're going to draw a reference triangle. So please draw a reference triangle that would have this as its hypotenuse. Remember, a reference triangle must connect back to the x-axis always. So there's my reference triangle. Using the coordinates of that point, could you please label how long these 2 legs of the reference triangle are? How tall is this triangle? I'd say it's 3 units tall, right? Because the y coordinate is -3. Now I'm not putting a -3 here because I don't need to worry about positives and negatives. We already dealt with that. The nice thing about a reference triangle is it's a physical triangle, so it's always going to have positive sides. Some people like to put positives and negatives on their reference triangles. I don't. I just deal with them before I even make the thing. Okay? That's 3. Would you agree that this would be 4? And do we recognize the most common special right triangle we got here? 3, 4, 5 triangle. If you did, and if it wasn't something that we already knew, we would have to do Pythagorean theorem to find this. Okay? Cool. Go ahead and finish it up. Oh, I didn't mark my reference angle yet. My reference angle would be here. Now, my reference angle is not theta. It's different from theta, but that's okay. It's still going to be, sine is still going to be opposite over hypotenuse. And cosine is still going to be adjacent over hypotenuse, and so on. All right, let me know if you got any questions on that one before we move on to number 14. Questions? If you read through the instructions on number 14, they seem pretty complicated. It says state the sign, positive or negative, of the sine and the cosine and the tangent for the values of t in the given interval. And then they give for number 14 pi over 2 comma pi. They're giving us an interval here. They're telling us only focus on angles between pi over 2 and pi. Okay, that's what they're telling. When they say interval given, that means all of the angles in between pi over 2 and pi, not including, because it's parentheses and not square brackets, right? So what they're telling us is that t could be any angle between pi over 2 and pi, and they just want us to figure out, is sine t going to be positive or negative? Is cosine t going to be positive or negative? Is tangent t going to be positive or negative? So all we really need to do to answer that is to answer what quadrant are they asking us about? Good. So if you're familiar with pi over 2, that's 90 degrees. Pi is 180. From 90 to 180, we're talking about quadrant 2. We're talking over here. And what do we know about points in quadrant 2? Negative cosine, positive sine. So sine's positive, cosine's negative, tangent's sine over cosine, which ends up being negative also. We feel okay about doing a couple more of those. My students always ask questions about those because the instructions seem a little bit weird. Moving right along to number 32. The instructions say evaluate without using a calculator by using ratios in a reference triangle. We're specifically told to use a reference triangle here. They would like us to find the cotangent of 13 pi over 4. Pi over 4. Man, I don't know where that is. Let's see if we can find a friendlier version of that. The cotangent of 13 pi over 4 would be the same as the cotangent of, what will we get if we subtracted 2 pi from 13 pi over 4? 5 pi over 4? Is it 5? Yep. 5 pi over 4. And 5 pi over 4, I know where that is. They want us to do a reference angle or a reference triangle, so we need to actually get this in the right spot this time. When I think about 5 pi over 4, I think about multiples of what? Pi over 4 is how many degrees? That's 45. So I'm going to start at 0, and I'm going to count 45 degrees, and I'm going to count it out 5 times. So here's 1 gets me to there, 2 gets me to there, 3 gets me to there, 4 would get me to here, 5 would get me to here. This is my spoke for 5 pi over 4. So we are dealing in the third quadrant. Let's go ahead and figure out whether this thing is going to be positive or negative right now before we forget. Okay, I always do positive and negative first because if I don't do it first, I'll forget to do it at the end. What do you think? Positive, because what are my x and y coordinates in this quadrant? They're both negative, and cotangent's the same as tangent, which is sine over cosine. Negative over a negative is going to be positive. So it will be positive. I'll just make myself a note of that because of the quadrant that's in. Would you please draw me a reference triangle? And then once you've drawn yours, can you please look up at the board and tell me, what did I do wrong here? Is that a proper reference triangle? No, it's not. Reference triangle must connect to the x-axis, not the y-axis. Avoid that mistake. It's kind of the big one for this section. Draw me a reference triangle, and then tell me what this reference angle is. And let's talk degrees now that we've got it in the right spot. What is the angle of my reference angle? How many degrees is that? Weren't each of these little wedges 45 degrees? So then this is 45 degrees. Cool. So if I want the cotangent, then I just need to figure out what my opposite and adjacent sides are. Man, if there's only a way that we could put some numbers into this 45, 45, 90 triangle. Jeez. Oh, no, wait, we know those. We've been working hard. I've been threatening you with a quiz about this all week. By the time it comes, everybody's going to ace it. That's my goal. We'll do it Tuesday. Our first bonus memorization quiz is scheduled for Thursday next week, by the way. And there's information about CWU on Canvas as well. The registration window doesn't open up until the week after next. But there's info on there with all the dates and stuff. All right, let's finish this up. Cotangent is adjacent over opposite, which would be 1 over 1. So our final answer is positive 1, and we're good. All right, you guys are doing great. Number 40 is up next. Any questions on 32 before we move on to 40? Number 40 says, find the sine theta, the cosine theta, and the tangent theta for the given quadrantal angle. Oh, I spelled quadrantal wrong. Oops, sorry. It's not I-L-E at the end. It's A-L. My bad. If the value is undefined, write undefined. Okay, so number 40 asks us to examine the angle 11 pi over 2. Yeah, that's a quadrantal because all of the angles that are something pi over 2 are going to be quadrantals. Don't really like 11 pi over 2 because it's not one of the angles I'm familiar with. So why don't we fix that? Why don't we find the coterminal angle for this? 3 pi over 2? We're subtracting pi over, or subtracting 2 pi, but we're thinking of it as 4 pi over 2. So if we do 4 pi over 2, that gets us to 7 pi over 2. That's still too big. Minus another 4 pi over 2 is, so 7 pi over 2. Minus another 4 pi over 2. But I agree. You're right. It is 3 pi over 2. And I know where 3 pi over 2 is. 3 pi over 2 is right here. So we need some x and y coordinates. I'm just going to use my unit circle x and y coordinates. That would be 0, -1. And what do they want us to do with this again? Oh, they just want us to find the sine of 11 pi over 2 and the cosine of 11 pi over 2 and the tangent of 11 pi over 2. Now we're doing 3 pi over 2 instead, but that's okay because the sine, cosine, and tangent are going to be the same. I would like you to avoid putting equal signs in between these, though. 11 pi over 2 is not equal to 7 pi over 2. They are coterminal, but they are not equal to one another. They just happen to match exact values for sine, cosine, and tangent. All right, cool. So we just need to remember which one goes with the x, which one goes with the y. Write our answers down. And we're good to go. All right, we got one more to do. This one's the trickiest one. Potentially, for some people, these types of problems will be some of the the most difficult of the unit. We will be practicing these a lot. Well, let's do the first one together here. So I'm going to write out the full instructions because it contains a lot of information that we need. So find sine theta and cosine theta if, and then I'm going to put this on a separate line, 46, cotangent theta equals 3/7, and secant theta is less than 0. All right. So at the end we're gonna write sine theta equals something and cosine theta equals something. We know that's what our answer is going to look like. So let's go ahead and set it up so we can kind of keep our goal in mind. Do you guys do this when you're working your problems? Kind of set your answer up as soon as you start the problem. It helps me sometimes to sort of focus me on what I need to do. So here's what I'm thinking, because I've done these problems a little bit. I feel like we should be able to use 3 and 7 to fill in some sides on a reference triangle. That's probably what we're going to end up doing. I know cotangent is adjacent over opposite, so I'll be able to put the 3 and the 7 in those two spots once I figure out where my triangle is and where my reference angle is. So the kind of the big thing that we got to do at first is figure out which quadrants. So the number one question that we're going to ask is which quadrant? And they're always going to give you enough clues to figure this out, and it's usually going to be based around sine, cosine, and tangent and whether they're positive or negative. So this piece of information right here tells me if cotangent of theta is 3/7, then what do I know about the tangent of theta? And I'm not interested in numbers here. All I want to know is tangent theta positive or negative? It's positive. It has to be, right? If cotangent's positive, then tangent has to be positive. So the first piece of information that I pull out of this is I know that the tangent of theta, wherever theta is, the tangent is positive. What information can we glean from the fact that the secant of theta is less than 0? If secant is less than 0, that tells us something about, secant goes with cosine. It tells us something about the cosine of theta. If secant's less than 0, is secant positive or negative? If secant is less than 0, then secant is negative, which means cosine is negative also, right? Secant and cosine go together. All right, so I've got the fact that the tangent is positive and the cosine is negative, and that should help me narrow down which quadrant we're going to be in. Think about this. In what quadrant is your cosine negative? There's 2 quadrants where the cosine's negative. Those x coordinates are negative in these 2 quadrants, and only one of these 2 quadrants has a positive tangent value. That is quadrant 3. Yes, 3. Thank you. That has to be in quadrant 3. That is the only place where tangent's positive and cosine is negative. So we've got our quadrant 3, so now we can go ahead and draw ourselves a reference triangle in quadrant 3. And mark our reference angle. Oh, I almost forgot. Geez, before I get too far into this, positives or negatives on my answer. As soon as you can figure out whether your answers are going to be positives or negatives, then go ahead and do it. We know, now that we know what quadrant it's in that quadrant sine is negative and so is cosine. Okay, so as soon as I got that it was quadrant 3, I was able to say, oh yeah, we got negative sines and cosines. Then we take and we do our reference triangle. Cotangent is adjacent over opposite, so we'd have a 3 and a 7 here. If we're talking sine and cosine, we're going to need that hypotenuse as well. How do you suppose we're going to find it? Good old Pythagoras. Are you guys okay with me just jumping ahead to the answer for this, for the Pythagorean theorem? Some of you might have it already. Maybe I can't because I think I've lost it. Never mind. I'm going to call it, well, 3 squared plus 7 squared equals the hypotenuse squared. That's 9 plus 49, which is 58. So the square root of 58 is h. Now we got everything we need. So our reference triangle is going to give us then the values for our fractions here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And I ran out of space, so I'm just going to make a note here. All right, there's a lot of moving parts in this problem, huh? You got to know a lot of little facts. So big facts from today is we have learned when sine, cosine, and tangent, what quadrants are they positive and negative? And if we're not dealing with a quadrant, then we're on a quadrantal. In that case, we just look at the ones and zeros on the unit circle, right? There is a mnemonic for this. I didn't show you guys this. I'll tell you, I'm not a huge fan of this mnemonic because it's kind of a gimmicky thing that'll help you remember it. But the true power of the positives and negatives is thinking about what quadrants it's in. But I'll go ahead and show you because at some point you're probably going to see it. I don't want to hide anything from you. It is this. We remember the sentence, all scholars take calculus. All scholars take calculus. And what this does is it tells us in each quadrant which of the trig functions is positive. They are all 3 positive in this quadrant. In this quadrant, only sine is positive. In this quadrant, only tangent is positive. In this quadrant, only cosine is positive. I personally think you would do yourself much bigger favor by thinking about positive and negative x and y values, because that's going to help you see some connections that we're going to be using later in the year. But whatever works for you guys. All right, that's all I got for you. Do you have any questions? I told you this is going to be a big one. All right. We're going to have some questions when we come back on Tuesday. We'll be back on Tuesday. I think we're going to have school on Monday, too. It's not going to be that bad.